Number 7. An unknown gas effuses through an opening at a rate of 3.16 times slower than neon gas. Estimate the molar mass of this unknown gas. So we don't have an absolute rate. It's one of the things that Graham's law is kind of weak at. It doesn't give you all the time an absolute speed. It's kind of difficult to do that. But what we can do a lot of times are relative rates. And that's what we have here. 3.16 times slower. We don't know what the actual speed is. We just know that it's 3.16 times slower. That's it. So if this unknown gas is 3.16 times slower, right? Slower, that means it must be heavier, right? Because these are going to be at the same temperature, so they're going to have the same kinetic energy. And so if it's moving slower, it must have more mass, or else the relation will be inappropriate. So these are the things that we know. We know that the rate of A is 3.16, right? It's 3.16 times faster, whatever rate B is. And so to make it super simple, we'll just have rate B be 1. We'll have it be 1. Again, we don't have absolute rates here. They're just relative. 3.16 times 1 is 3.16. So this actually makes it a lot easier on us. So we have rate A, we have rate B, we have the molar mass of A because the question told us it's neon. We look at the periodic table, it's 20.18 grams per mole. And so we're asked to solve for the molar mass of B. And so we'll use our Graham's law over here and we'll rearrange it, right? To have the square root of molar mass of B is equal to the molar mass square root of the molar mass of B is equal to square root of molar mass A times velocity A divided by velocity B. All right, plug these in here. Plug them in. We get 14.2. 14.2 is going to be our calculation at the end of this. But we do have to square this because this number, 14.2, is equal to the square root of molar mass B, right? Don't forget that. This value right here all equals 14.2, but we still have to get rid of this radical right here. So we square both sides. That'll get rid of the radical. We have to square 14.2. Plug that in the calculator. We get 201.509. Well, I'm using 3 significant figures because of this number right here given to me by the question, 3.16. So I'm going to round to this spot right here. This 5 tells me to round this up. So I have 202 grams per mole.